All right, so I'm going to show you what we learned today in class. Since tomorrow we have a review day followed by the test, I want you to be able to make sure you caught yourself up. So this first problem right here, we skipped over. It was a warm-up. It was once again like practicing using your calculator, finding maximums. And I wanted to make sure that, I was spending quality time going over problems in class that you would be tested on. So we skipped that. We'll save it for later. We will learn it, but we just didn't do it today. Okay, so what we did talk about today is average rate of change. So I said it a lot in class today because I want you to get used to seeing average rate of change. Average rate of change you also need to know is synonymous with speed. So in a word problem, if you saw how fast was this going or what was the speed, they're asking you for average rate of change. So when you know those two things are connected, the last thing that you have to know is that both of those terms are synonymous with slope. So what we're actually doing here is that I will be asking you I'll be giving you a function. It could be a quadratic, cubic function, whatever it looks like. So for example, this one right here in the model, it is a downward facing quadratic function. And I'm going to ask you to find what is the slope of the secant line, or what's the average rate of change from, and then I'll give you two x values from x, let's say from 1 to 6, okay? So what you're going to need to do here is that you're going to need to find these points location. Obviously, this one's over 1 and this one's over 6, but we need to find the y value so you can find the slope of the secant line, because that's the average rate of change. So what we did in class here is we did these two problems. Okay, I started off by doing A with the class, and then everyone did B on their own. So I'll do the same thing here with you so that you can see how it works. So first off, I said, notice that this function right here, okay, f of x equals negative 2x squared plus 4x plus 6, that's a downward facing parabola. Notice at the bottom of the screen here that you have that same function graphed. Now, is that going to be graphed in all problems? Absolutely not, but it's just that we can see what we're doing at first. Okay, so I'm finding the average rate of change, which is the slope of the secant line. On the interval, first we're going to do negative 3 to negative 1. So if you look at this graph right here, if you look at where the function hits at negative 3, it's right here. If you look where it hits at negative 1, it's right here. So what we're actually doing is we're finding the slope of this line. So now we know how to find slope. We just need the location of this point. So I know it's over negative 3, but how much is it down? So realize I gave you an x value. To find a y value, all you have to do is plug in the y value into this function. So we explained that, and then we said, okay, this point right here is negative 1 comma something. Once again, to get that y value, plug it into the function. Then you'll have 2 points, and you can do the slope formula. So going back up here, that's what we did. We said, all right, I want to know from the x value of negative 3 to the x value of negative 1, what is the average rate of change, or slope, or speed. So we're going to start by seeing what the y value is at negative 3. So we're going to do f of negative 3 is equal to negative 2 times negative 3 squared plus 4 times negative 3 plus 6. So all that I did there was plug in that negative 3. Now you need to clean it up. This is 9. Negative 2 times 9 is negative 18. 4 times negative 3 is negative 12, and then plus 6. Negative 18 and negative 12 is negative 30. Negative 30 and 6 is negative 24. So this gives us the point when we plugged in negative 3, we got a y value of negative 24. So now realize what we just found. We just found that this point's at negative 3, negative 24. Going back to where we were, now we're going to do the same thing, but with negative 1. So now we're going to find f of negative 1. Negative 2 times negative 1 squared plus 4 times negative 1 plus 6. This is positive 1 times negative 2 is negative 2 minus 4 plus 6. Negative 2 minus 4 is negative 6, plus 6 is 0. So this gives us the point when we plugged in negative 1, we got 0. Now that we know those 2 points, we can find the average rate of change because average rate of change is the same thing as slope. So if I call this x1, y1, this x2, y2, I can use that slope formula right there to find the slope of the secant line. M equals y2, which is 0, minus y1, which is negative 24, so I'm going to change it to plus, over x2, which is negative 1, minus x1, which is negative 3, so once again, I'm going to change it to a plus. That gives us 24 over 2, so the slope of the secant line, or the average rate of change, is 12. So next, what we did in class is that everyone tried that with 2, 5, and they got the slope as negative 10. You should try it too, just to make sure that you got your process down. But once you're practicing it a lot, it seems to go, people have seemed to be catching it on. Okay, so then we did another one. Same idea, find the average rate of change, plug in negative 2, see what you get, plug in negative 1, see what you get, slope formula. So once again, I let people practice that on your own. We step-by-step compared answers. So you can practice it on your own too, check to make sure what's on Schoology, and it should be fine. 4, same exact thing. And then when we got to 5, these are word problems. So on problem number 5, I told everyone they could take out their calculators, but not because we need them, but it's just going to be easier to use for these computations. On your test, the numbers will not be decimals like they are here, and they will not be very big, so you won't need a calculator for it. For example, like in this, you have to know what 2 squared times 1.7 is, or 2.7 is. On your test, it'll be like, what's 2 squared times 3? It's not with decimals. Okay, so here we read through the word problem, so you can do that too. And basically what it talks about is an object falling, and this is the equation for an object falling, where h, this h right here, is the height of the object in feet after it falling. T, that variable right there, is the time in seconds. And finally, h naught is how you say this, is the initial height. So the height of the building it fell from, or the height of the mountain it fell from, the initial height there. So after reading this, it says, what do you need to know to work with this problem? Well, we were never given the height of the building. So the height of the building is 1,450 feet. I'm giving that to you now. So we can adjust our equation now. Instead of plus h naught, we can say h equals negative 16t squared plus 1,450. So word problems are the same idea here. If you read through it, it looks very similar to the ones that weren't word problems, except for it also says that we want you to find and interpret with correct units the average speed of the object. So I'll do that in problem B, and then notice problem C and problem 6 are the same exact thing. So if you just look over those examples when I'm done going over this one, you should be fine. So here it goes. Find and interpret with correct units the average speed. So average speed, remember that's the same thing as average rate of change, which is the same thing as slope of the object for the time interval of 1 to 2 seconds. So it's just like what we just did. We are going to find, and this is not in function notation, I'm just going to write it in function notation. So we're going to find the height at 1 second. Plug in 1, negative 16 times 1 squared plus 1450 is 1434. And I have the answers memorized because I did this 3 times today with class, so you could be plugging that into your calculator. That gives me the point 1, 1434. Realize what this means. It means after 1 second, the object is now 1,434 feet off the ground. Next, h of 2. Negative 16 times 2 squared plus 1450. 2 squared is 4, 4 times negative 16 is negative 64, minus 50, so that's 1386. Okay, once again, we used a calculator for it. I was just trying to do the mental math quickly. So we have the point 2, 1,386. Once again, after 2 seconds, now the object's only 1,386 feet off the ground. So now we want to find, on average, on that interval of 1 to 2 seconds, how fast it's falling. So we're going to use slope formula, 1386 minus 1434 over 2 minus 1. That gives us negative 48 over 1. Therefore, the average rate of change, the average speed, is negative 48 feet per second. So remember, this was feet and this was seconds. So feet per second is our rate. So there's us finding with correct units. Now we need to interpret. So realize that negative represents the fact that it's falling. It's not that it has a negative mile or feet per second rate. So we can interpret what that means now. We can say on average, because remember this is average rate of change. On average, an object falls 48 feet per second. And then we can't just say that's what it does, because obviously as it continues to fall, it's going to get faster and faster and faster. So we have to say on what interval that's happening. So we're going to say on the interval of 1 to 2 seconds. So the next problem is exactly the same, but you're plugging in 5, plugging in 7, interpreting it, which is the same interpretation, but with a different speed now. And then the last one is just a different equation with the moon. So notice it's using the same idea throughout the entire notes, and it is, inputting, getting an output, and using the slope formula, so it shouldn't be that bad.